hello students. This is your Vita again with another video on class 11 science, and the name of the chapter that we are going to do is work, power, and energy. Now you have basically studied this chapter in your class 9, okay, and it was completely the same only. But now the thing which you are going to study in this very chapter right now, it's a bit of descriptive, okay. Like there will be a little bit of angles, little bit of trigonometries involved in all these things. So yes, and it's a very important chapter as well. So please do pay attention, okay. So this chapter will be completely divided into three parts as the name suggests, right? Work, power, and energy. So as the name suggests, we are going to start with work, okay. So if you have studied in class 9, what you have studied in class 9, I'll just reiterate the very same thing again. Suppose for example, this is a plane surface, right? This is a plane surface, and then I have a block of wood, okay, a block of any solid substance, okay. I have a block of any solid substance. जब भी तुम लोग काम करते हो, right? Whenever you do any kind of work, the first thing which you need to do is you need to apply a bit of force, right? It can be push or it can be pull. Imagine I'm applying a force F over here. Okay, I'm applying a force F over here. Now, what we have to do in this very situation is that the moment when I apply force, if that very force produces displacement, okay, that means an object was initially in this very position. Now, what happens after some time, that very object, it moved to this very position. That means there is a bit of displacement, right? Okay. Now, when I apply force, right? When I apply force to produce a bit of displacement, that very situation is known as what? Work. The thing which you are doing in that kind of scene is known as work. जो चीज तुम कर रहे हो, उसी को मैं क्या बोलता हूँ? उसी को मैं बोलता हूँ work. I hope this is clear to all of you, right? It's very good. Right, so based on this, I have just written the definition. You can just pause the video and you can write down the definition for yourself. Now, what is the definition? If you just see this, work is said to be done, right? When can I say that work is done? Work is said to be done by a force when the body is displaced through some distance in the direction of force. That means if I apply the force, अगर मैंने कोई भी object को, suppose ये मेरा wooden block था, मैंने इसको धक्का दिया. If it does not move, that means there is no work. But if it produces a bit of displacement, that means what? That means that it is producing what? It is producing something known as work. So now, based on this, I can write two conditions for work, right? Now, what are the two conditions? Okay, if I write it down, the following, I'm just writing this down. Condition suggest that work is done, right? And I hope you can easily find out what are the two conditions, right? It's very simple, right? दो conditions obviously क्या होंगे? What are the two conditions? The two conditions is, first of all, there should be an application of force, right? So that means force should act on the body. Okay, this is the thing, right? Force should act on the body. What is the next condition that I am supposed to use? The next condition that I will be that I have to use for producing work is that there should be the next thing is there should be displacement. Okay, that is very important. Okay, I hope this is clear, right? So I hope the definition of work is completely clear, and based on this, there are two conditions of work. Okay, now that's the scenario, the entire thing. Now I already know, we have already studied that force is what? What is this force? Force is a vector quantity, right? And displacement is what? Displacement is also a vector quantity. I already know about this, right? Force is a vector quantity and displacement is a vector quantity. But work is not a vector quantity, right? Because work doesn't need direction. It's a very simple thing, right? Work doesn't need direction. Now if I try to write the formula for this, how will I write this? It's a very simple thing. Just you can pause the video, you can just rewind the video to write this down. Okay, how will be the formula of work now? Now work will be equal to what? Work will be equal to, obviously this work is going to be what? I'm just writing it down here. Obviously this work is going to be a scalar quantity, right? Because work doesn't need direction. It's a very simple thing. It is going to be a magnitude of force, right? And displacement. Now will it be a cross product or will it be a dot product? I already know about cross product and dot product. What is cross product? Cross product, the other name of cross product is vector product, right? You've already studied this. What is the other kind of product is dot product, right? Now this dot product is also known as scalar product. So here what kind of product will I be using? I'll be using the dot product here, okay? So that means the dot product of force and displacement will give you what? Will give you this one, will give you work which is also a scalar quantity, okay? Now this is what? This is work done by a constant force. If the force is constant, okay, work done by a constant force. Okay, if the force is constant all throughout, then that kind of thing might come. But what if the force and force is not constant, like it is inclined a bit? Okay, so what you can do, you can just pause the video and you can write down the formula and I'll rub it down. Okay, now imagine I'll just give you a situation here. Suppose, for example, this is my plane, okay, right? And then I have a box over here, okay? And then I have a box over here, right? Now what happens actually in this very situation? I'm applying a force now, right? This time the force that I'll be applying will be not in the direction. जैसे कि previous case में मैंने क्या किया था, the displacement was in this direction, the force was also in this direction. But this time, let us make, usually it is not, it might not be in this kind of situation. Let me try to apply the force in this very direction, okay, inclined to some angles, right? So this is my force, and my displacement is obviously in this very direction, right? Now this, the displacement will be in this direction. Now let the angle between force and displacement be theta. We already know about this, right? Let the angle between force and displacement be theta. Okay. So now after some time, what is happening now? The object reaches here. Okay. Right? And this very length. Okay, just I'm writing this down. Right? This very length is nothing but this very length is known as S. Okay? It's completely clear. Now, what might happen? I can split this force. I can split this force. Listen very carefully. We already know that we can split a vector into two components, right? Component along x-axis and component along y-axis, right? So when I split this force along x-axis, it will be something like this. This will be your x-axis, right? Again, what is happening? This will be my force along y-axis, right? I'll just try to put this at the top. Okay, so W is equals to force into, okay, that's the scenario, right? After some time, what is happening? The very same thing, okay? This is my force, this was my force, right? This was my force, and this is the component along x-axis, f of x, and this is the component along y-axis, f of y, right? I hope this is clear. So just let me write this down. So now this f of x what is going to be this f of x? We already know that f of x is nothing but the cos theta part, right? So the magnitude of f of x is going to be what? F cos theta. We already know about this, right? Okay. Then what will be the component along the y-axis? The component along y-axis will be something like this, f sine theta. I hope this is also clear to all of you, right? Just what you do, you can pause the video and then you can write this down. Okay, I'll just write here uh, the two components of f vector are number 1 and number 2. Okay, now this will be the base component, right? And this will be what? The perpendicular component. Okay, I hope this is completely clear to all of you, right? It's there should not be any doubt regarding this. But now if you see properly, just see, एक बार notice करो, ध्यान से देखो एक बार. It's not very tough. If you notice this, the impact of force was completely along this direction, right? So that means what? This force was not effective at all, right? So this force was not effective at all. So that means this very component is going to have how much? It's going to have a zero impact, right? So that means this formula, when it is inclined in certain angle, I can write this formula as what? I can write this formula as f cos theta into s, or I can also write this as fs cos theta. That is what dot product is, right? So this is how the thing actually is. Okay, so this is the formula for work done. So I can also say work done is nothing but it is the dot product of force and displacement, and work is what? Work is a scalar quantity, right? So yes, this is a very important formula, so you can write it down. You can just pause the video and then you can write it down. Okay. Okay. Now we are done with this formula, right? So W equals to Fs cos theta. Now I already know that whenever I involve this dot product, right? Whenever the dot product is there, that means the cos theta part comes, right? If it is cross product, then the sine thing comes, right? Now since it is a dot product, since it is cos, so obviously I can say that it is what? It is a dot product. So I can also define work as work done is the dot product of force एंड डिस्प्लेसमेंट. ठीक है, डॉट प्रोडक्ट है, cos थीटा आया है, इसका मतलब क्या हुआ? इट इज नथिंग बट इट इज गोइंग टू बी द डॉट प्रोडक्ट. Imagine if it was something like this. Imagine if it was f just a second. Imagine if it was fs sin theta, right? So that means what? It was supposed to be cross product, but it is not sin theta, so that is why it is going to be a cross product, right? Okay, so hence I can also say that work is what? Work is a scalar quantity, right? That's done. Now you can pause the video and you can write this down. Let's go for this one now. Now let's understand the two cases. First case is when f and s are in the same direction. Okay, तो अभी देखो s भी मेरा इस डायरेक्शन में है and f is also in this direction. Okay, f is also in this direction, s is also in this direction. Okay, now what is going to happen in this kind of scenario? You can see the value of theta is always going to be what? The value of theta is going to be 0 degree. ठीक है, clear? Since it is going to be 0 degree, so the work done will be what? Force Fs, right? Let me just write it like this. Fs cos theta. That means Fs cos 0 degree. Now if I use this cos 0 degree, what is the answer going to come? The answer is going to come as Fs, and I think this is going to be the maximum value, right? यही तो maximum value हो सकता है. So that means I can write therefore work done is maximum. Remember this situation, okay? Work done is maximum when F and S are in same direction. Okay, are in same direction. Okay, this is the first condition. Okay, let us go to the next condition. अभी हम लोग next condition पे जाते हैं. If I go for the next condition, you can just see here f and s are perpendicular to each other. So that means f is like this and s is in this way, right? This is my f and this is going to be my s. Now both of them, they are going to have how much? 90 degree. I also call it as pi by 2, right? I also call it as pi by 2. Now in this very scenario, the value of work is going to be what? Work is going to be f s cos pi by 2. And the value of cos pi by 2 is what? The value of cos pi by 2 is nothing but it is 0. So yes, it is going to be 0. And then the entire thing will be what? The entire thing comes as 0. So that means there is no work at all. So that means when can I say the work is minimum? Work is minimum when they are perpendicular to each other. Okay, so just let me write it down so that you can copy this all by yourself. That is, work done is minimum when f and s are perpendicular to each other. Okay, I hope this is clear to all of you. Right, it's done. So what you can do, you can just pause the video and you can note down whatever I have written on the board. Okay, now let's go for this dimensions of work. Okay, so before knowing the dimensions of work, I'm just going from the base. मैं पूरा base से जा रहा हूँ, ठीक है? So if I go for the dimensions of work, first of all, I need to see the formula of work, right? Now the formula of work has force and displacement in it. Okay, force and displacement in it. First of all, I know the dimension of displacement is what? L, right? Let's know about the dimensions of force. You have already studied about this, but I'm just going to help you out with this as well. If I see the formula of force, the formula of force is mass into acceleration, right? What is the dimensions of mass? The dimension of mass is m. What is the dimension of acceleration? It is going to be L1 L t minus 2, right? Combining both of this, the dimension becomes as m L t minus 2, right? This is the dimension of, or if you want to write it as to the power 1 because to the power 1 is it's no point of writing this, right? Okay, now let's do this. Let's find out the dimension of this one. So force into displacement, right? Force into displacement. Okay, force into displacement. Now what I will do is I'll just put the dimension of force here. What is the dimension of force? I've already calculated this for you. This is going to be m1 L1 t minus 2, and then the dimension of displacement is L, right? Don't write this now. Let me just finish this. Okay, and then the thing comes as m1. Now this L and this L, this is also to the power 1, becomes L2 and t minus 2. Okay, so this is the dimension. Dimensions are very important, so please note this down. Okay, I hope this is clear. The dimension of work is m1 L2 and t minus 2. Okay, now after the dimension is done, let's come to the unit part. Okay, please pause the video and do jot this down. Okay, let's come to the unit of work. Okay, what are the units of work? Okay, unit of work. Now this unit of work, I'm just going to explain it to you in this one, in the form of a flow chart. Okay, so if I talk about the unit of work, there are two types of units that work can have. Okay, there are two kinds of unit that work can have. The first kind of unit is known as system of unit, to be more precise. Okay, अगर मैं और precisely अगर बोलना चाहूँ इसको, तो it is going to be like a system of units. ठीक है, absolute units, and the other one is going to be gravitational units. Okay, gravitational units. Okay. Okay, so the two systems of unit is absolute unit and a gravitational unit. Okay. Now, if I talk about absolute units, again, this absolute unit has two systems: the SI system, also known as MKS system, right? And then the CGS system. Okay. In the same way, the gravitational unit also has two systems. Okay. One is the SI system, and another one is the CGS system. If I talk about SI system of absolute unit, it is known as the SI unit is Joule. Okay, in SI it is Joule, and in CGS, okay, in CGS it is known as Arc. Okay, it is known as Arc in CGS. That means centimeter, gram, and second system of units. Okay, let's go to the next part then about the gravitational unit. If I talk about gravitational unit, the first one is going to be kg meter. Okay, I'll explain you how it is kg meter. I'll just explain you, don't worry about that. And then this one is going to be obviously gram centimeter. Okay, gram centimeter. This is an SI unit, and this is in CGS unit. Okay, so this is the thing. I hope this is completely you are clear with it. We are going to be more clear when I discuss about the units. So before that, you again pause the video and please write this down. Okay. 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 So now let's discuss the units of work. Okay. Like first of all, I'll start with the discussion of absolute unit of work. Okay. Now, when I discuss about absolute unit of work, I need to know the formula of work, right? The formula of work is, just see this, this is not connected to this. The formula of work is force into displacement, right? No problem with this. Now, what is the SI unit of force? The SI unit of force is Newton. And what is the SI unit of distance? The SI unit of distance is meter, right? If it is Newton and if it is meter, then the SI unit of work comes as Joule. That means 1 Joule of work means 1 Newton into 1 meter, right? So in other words, I can say that if I apply a force of 1 Newton, just see here, अगर मैं 1 न्यूटन का फोर्स अप्लाई करता हूं और मुझे 1 मीटर, बिकॉज 1 into 1 is 1, राइट? तो अगर मैं 1 न्यूटन का फोर्स अप्लाई करता हूं और मुझे 1 मीटर का डिस्प्लेसमेंट मिलता है, तब मैं उसी फोर्स को मैं क्या बोलता हूं, उसी वर्क डन को मैं क्या बोलूंगा, मैं बोलूंगा 1 जूल, राइट? सो एग्जैक्टली दैट इज द सेम थिंग. It is the SI unit of work, nothing difficult. 1 joule of work is said to be done, right? जब मैं, when I apply a force of 1 Newton. See, I've applied a force of 1 Newton. This is how you define units from formulas. Okay, when I apply a force of 1 Newton and displace the body through a distance of how much? Through a distance of 1 meter. If the displacement is 1 meter, right? On application of a force of 1 Newton, then that very thing is known as 1 joule. So I can write 1 joule, right? 1 joule, I'm just writing it here. 1 joule equals to 1 Newton into 1 meter. Okay, this is the case, right? Okay, done. Now, in the same way, let me go for the other one. Now, the CGS unit, right? Now, the CGS unit. When I go for the CGS unit, it is known as ERG. Okay, ERG. For this, what is the CGS unit of force? The CGS unit of force is dyne, and the CGS unit of distance is centimeter, right? Okay. So that means this will come as ERG, right? So that means how do I define 1 ERG? 1 ERG is equals to 1 dyne into 1 centimeter. That means if I apply a force of 1 dyne and I get a displacement of how much? I get a displacement of 1 centimeter this time. In the previous case, it was 1 meter, right? So now the displacement is 1 centimeter. So when I apply a force of 1 dyne and get the displacement as how much? I get the displacement as 1 centimeter. That very thing is known as 1 erg. Okay, so I hope this is clear as well, right? So just read the definition here. 1 erg of work is said to be done if a force of 1 dyne, it's a very important thing, 1 dyne displaces a body through a distance of 1 centimeter. Okay, displaces a body through 1 centimeter. in its own direction, then it is known as one dyne. So how will I write this down? You can see I can write this down as the one arc is equal to one dyne into 1 centimeter, right? This is how I'll do this. So again, pause the video and just write it down. Okay. Now let's come to this relation between Joule and Arc. Okay. How do I find out the relation between 1 Joule and 1 Arc? Okay. It's another important relation. So 1 Joule, okay, 1 Joule is equal to how much? 1 Joule, I've already discussed, is equals to 1 Newton into 1 meter. Right? Now 1 Newton, I need to convert this into arc, right? So for converting this to arc, I need to convert this Newton to what? This Newton to dyne, and this meter should be converted to centimeter, right? अगर मैं न्यूटन को डाइन में कन्वर्ट करूंगा और सेंटीमीटर को मीटर को अगर मैं सेंटीमीटर में कन्वर्ट करूंगा, only then the entire joule will be converted to arc, right? So how do I convert this? I hope all of you know about know the relation between Newton and dyne. Let me just show you this to you. Okay, it's a very simple thing. So I know force equals to mass into acceleration. I'll just do it very quick. थोड़ा जल्दी करूंगा. ठीक है? If you don't understand, you can rewind the video. Mass is kg and this is meter per second square, right? I need to convert this to dyne. To convert this to dyne, I need to convert this to kg. How do I convert this to kg? Kg to gram. Sorry, this will be 10 to the power 3, right? Gram, and then meter will be 10 to the power 2 centimeter per second square. The moment when I do this, it's gram, it's centimeter. That means this will become how much? Dyne. Okay, this is how. It's a very quick one because if you've already studied this. So 1 Newton. Okay, remember this. 1 Newton is equals to 10 to the power 5 dyne. Okay, you need to remember this. So I'll just use this value then. I'll just use this value. This will be 10 to the power 5 dyne, and 1 meter will be equal to 10 to the power 2 centimeter, right? This is coming as 10 to the power 5 and 10 to the power 2. It's coming as 7 dyne centimeter, and that is equal to how much? That is equal to arc. Okay, that is equals to arc. So that means 1 joule will be equal to 10 to the power 7 arc. Okay, I hope this is also clear. Again, the same process. Just pause the video and just write it down. Okay, thank you. Okay, so now let's come to this gravitational units. Okay, the other system. We are done with the absolute system. So in absolute system, we found out that in SI unit, it is what? In SI unit, it is your Joule and Arc. And now let's come to this one. Now let's come to the gravitational units. Now, when I come to the gravitational unit, SI system, as I've shown you in the flowchart before, that the SI unit was kg meter, right? Okay, so let's read this. Now, when I talk about this kg meter, what is this kg meter now? It is the gravitational unit of work in SI system, but there is a bit of an explanation to this. Okay, just try to understand this explanation. See, let's go deep now. I already know, since this is a gravitational unit, right? So gravitational pull given by the earth is also known as weight. Now weight is also equals to what? Weight is equals to mass into acceleration due to gravity. Right? I know this, mass into acceleration due to gravity. Now, if I see this, right, what is the mass? Suppose, for example, if it's 1, and then if this is as 9.8, right, 9.8, so that means combining both of this, what do I get? I get 9.8 Newton, right? Okay, that's the scenario. If the mass is 1 kg, right, and the acceleration due to gravity is this one, so it comes as 9.8, right? Okay, we already know that there is one unit of force, also known as kg weight, or I might also call it as, sometimes I might also call it as kg force, right? When I apply a force of 1 kg weight, that means when the earth, since it is about gravitation, when the earth is pulling you with a force of 1 kg weight or 1 kg force and then displaces it through a distance of 1 meter, और अगर 1 meter से displacement होता है, that very unit is known as 1 kilogram mass. Okay, 1 kilogram meter. Okay, now let's come to the units. Now let's come to how it is related with this one. Okay, it's a very simple one. If I come to this, देखो 1 kg